Hello, this is Trevor. Today we're working on an algorithm or JWT lab in PortSwigger's Web Security Academy. It is authentication bypass via algorithm confusion. So it uses a robust RSA key pair. We're going to use algorithm confusion attack. We're going to try to get the server's public key. Oh, and exposed via standard endpoint. That's good. Sign and then add access to the admin panel. Delete the user Carlos. We have our own credentials. There's that. Let's check the hint. And okay, that's important. Sweet. All right, let's check out the lab. Please remember to like and subscribe. Leave a comment. Let me know how I am doing. I would appreciate that. Also, let me know, because we're approaching the end of these, what you want to see next. What should I do next? It can be more web app stuff. It can be, try hack me or anything else that, I'm able to stream. All right. What do we want to do? I want to go to my account, get a session token, and then let's take a look at it. Wiener Peter. We're going to talk a little bit about what an algorithm confusion attack is. I'm going to copy that, and I'm going to go to 5, open up Chrome, token.dev, recon. I don't really see the need on this because it tells us exactly what the vulnerability is. Understood. Awesome. Thanks, man. Hopefully you'll find it useful. We'll do some cool stuff. So it uses a KID. It uses RS-256. And here's the user. Here's the public key. I think that's the public. No, it's probably not, because I don't know how this signature, if this was the actual public and private key, we wouldn't get this. Never mind. So it's definitely not. What is algorithm confusion? Algorithm confusion is, so RS-256 signs the key with it's a PKI, so it signs it with the private key, and then uses the public key to verify the signature, right? If we were to use the public key as the key, as the secret, and then use HS-256 to sign that message with, the HMAC SHA-256, using the public key as the secret for that signature, change this algorithm to HS-256, there's a chance that the endpoint, the server, will see HS-256, look around for this key identifier, see that it's a public key, and then use that as the secret to decode to sign the message and validate the signature in the message. And so basically the vulnerability is that the code on the server side doesn't require RS-256 when it should. So hopefully that makes sense. That's what we're doing. The server expects to use the public key. When it sees HS-256, it automatically just grabs the public key and then tries to sign it using that as the secret in the HMAC SHA-256, compares that signature with the one we sent. If they match, it trusts everything in the in the token. Cool. So we need our job is to find the public key. Once we found it, then we need to use that, get it in the proper format. It needs to be a byte for byte correct format. And that's why this hint is important, so we know the exact format the certificate needs to be in when we do our signing, so that the server signs it in the same manner. And then once we get that, we'll use it to sign the certificate, and then modify the user account to administrator. Awesome. Let's get going. Let's start our script. So I'm going to go to here, Python utils, utils / create. What is it? Create script, like that. That's going to build our template. I'm going to copy this, put it in our command history, just so I can arrow up, and then I'll vim JWT authentication bypass via algorithm confusion. Let's start off getting the token the same way we did in the last one. So we'll just log it, make sure we've got that working. There we go. And let's try to find the public key. So most of the time they're in .well known. I don't remember. Let's go here. I'm going to do copy link. Well-known something keys. I'm going to search for .well. There we go. Let's check here. 2, 3. What do I want? I want 2. Proxy, HTTP history. We're going to send this to repeater. In repeater, I'm going to change this to that. Move that. Send it. Not found. Okay. Let's see. Is there any other? Only one. Let's look at algorithm confusion. See if this has something. Control F dot well. Here we go. /JKS JSON or that one. There we go. Okay, so we've got it in a JKS format, which is awesome, because now we get to figure out how to turn it from JKS to PEM. Sweet. Let's download this, get it from JSON. No, let's leave it in JSON, actually. So blog.get response, we want that to be this URL, jks.json. So that's blog.base URL plus jks.json. Did I? JWKS. And then we're going to save that response. Response equals, and we're going to print resp.text just to make sure we have it. And then I assume we're going to get it. So I'm going to save this. There's the encoding detection as most. Oh. So do I need to decode it as ASCII? What did it? I've never seen that before. Coding detection. Print. Let's try it. Resp.decode ASCII. Does that get rid of it? No. Oh, I need resp.text. Nope. Whatever. Well, it gives us the error. Let's check. So, JWK, we want, this is the original. No, we can just name it JWK. It's not like we're going to build another one. JWK equals resp.text print JWK. ASCII is most likely encoding detection. What the crap? How do we... Should I like encode it and then decode it? JWK equals JWK.encode .decode. This seems dumb. JWK. Seems real dumb. Where is that? Char set. Oh, is it because the HTML document doesn't have a char set? Is there a way? Do I care? Let's see if I care. So I want to do F blah. I just want something to separate this from the error. Because I want to make sure that the two are, yeah, blah. So blah does not include, this response does not include that error. So I don't care. JWK. All right. Now, because we're going to use pi or JW, let's look. Let's look at, what did we use this one? We're going to use this library, JW Crypto, the same one we used before. I don't think, whoops, not here. This one. I don't think we'll need all of these. Oh, we are going to create a JWK. So we'll do JWK text equals that. And then let's go here and look up JW crypto, read the docs here. And we want to create a JWK from a JSON right here. From JSON. The reason I want JWK is because then I should be able to do some export, or this is export something. We don't want a JWK set. Let's see, but I should be able to export to PEM. That's what I want. Sweet. So number one, we're going to import it. We're going to do from, what was it? From JSON. And then we'll do convert it. So JWK equals JWK.from JSON JWK text. Let's make sure that doesn't error. Yeah, it does. JWT. Oh, you know, I probably need .jwt. Oh, JWK. JWK dot. That's what I think. Let's check. The class is JWK. So JWK. that works. Local variable. Oh, crap. Yeah. None. Invalid JWK type. Unknown type. So we want RSA. Did I forget to export to band from key? I must have to put so unknown type, none. So let's try this. Let's convert it, the JWK text, to a Python dictionary. So I'm going to do JWK dict equals JSON.loads JWK text. The reason I'm doing that, so I'm going to import, is so that now I'll be able to do JWK dict KTY, which is the key type, equals RSA. And then we'll do JWK text equals JSON.dumps JWK dict. So I'm just making it a dictionary, setting the key type to RSA, and then dumping it back to a string. And let's see if that fixed the error. Missing n value. What do you... Oh, this is a JW key set because it has keys. Oh, and here's the KTY. So it did have that. But because this is keys, so an array of keys, and I'm saying array here because it's JSON and not Python, in case you're wondering. So we do need this down here, which is the JW key set. Hopefully we have, hey, what's going on, Rilovich? Hopefully we have the same imports using the standard JSON. We can do import key set. So we're going to change, getting close. So I've done it for 200 or some odd, but not all of them. JW key S is resp.text, and then we're going to name this JWKS for JW, and then we're going to go here, look at this JW key set. JW key set from JSON. No, it's not from JSON. Oh, it is from JSON. JWKS. All right, and then let's do print dir of JWKS, right? Dir will show us all the methods available if it works. It does work. It looks like it's like a regular list. It does have get key, but it also has items. So we could probably do print JWKS and get the first item. Nope. Do we need to like do items? Items or get? How do we get one of the keys that has dict items? Should we do keys or get key? Dict keys. What? Let's try get keys. I wonder what that get. We can actually refer key ID. Gets the key from the set param ID, but we'd need to know. Let's see if there's anything else better here. How are we? And also we'll look at the set default. I guess we need this. Get keys, the matching KID. So how do we, I guess we can get the KID from the JSON. So let's turn this into a dictionary like we did. JWKS dict equals JSON.loads JWKS text, and then KID equals keys JWKS dict keys, and then we'll want the first one, and then we'll want the KID. Print KID. See if that works. That looks like it works. And then here we can do KID. What was the, there's the KID here. Ah, nice. Well, it only, what the crap? Get keys. I guess it says return type. Oh, gets a key from the set. Return type JWK. Okay, that's what we want. Get key. There. JWK equals this. We don't need this anymore, or this. We can do log.info f k KID here. What's the error here? Using, no. Never mind that error. And this one is a terrible name. So we'll do it as, I guess, underscore. I'm terrible at coming up with variable names. All right, now that we have the key, we should be able to export to PIM. Private key password. Underscore JWK dot export to PIM. Hey, a bit boy, thanks for the follow. I appreciate that. And let's print this to see what we have. Awesome. And we have the carriage returns at 64 characters. This should be properly formatted. We have an ending with a carriage return. I'm thinking that's good. Do we need to decode it? Probably. So let's try signing the JWT with it decoded. So let's do log.info, and we'll do fjwt. Have you ever gone to an H1? I have not. I don't even, I mean, yeah, I don't know what they are. /r/n. I know what HackerOne is, but not what a meaning would be. JW. We want, wait, what did I just delete? I want this. PEM equals, what did they talk about there? What is it? What is it like? Why should I go? That's my question. PEM. So let's check it out. You don't know? Ah, that's fair. I don't know either, so. Oh, let's decode this. Decode. Yeah, that's totally fair. I'll check it out. See if it's something I should be attending. Awesome. There's our PEM file in the logs. Let's decode it here actually, because I think we're going to just always need it decoded. And then let's sign the JWT. So what did I log? Original token. I have not done any of my stuff with this. Let's import my class library here. And here, let's load it. We're going to rip off what we did here and decode it. We can log this stuff. So we're going to let's see. Yeah, that is handy. And I honestly, when I was typing it, I was trying to remember how to do that. It's a very good point, Frank. It is it's handy when you do stuff like this. In fact, let's change one of these to that right now. KID equals, right? And let me figure out what I was doing here. So I was saving this as underscore JWT, like a crayon eating hacker. And then we're decoding it. We need something here. We need orig token. And then we're going to log the head and the body. And then let's go ahead and try signing it now. We're going to set the cookie, and then we're going to try to get my account. So blog.get response, blog.base URL, no, blog.my account with cookies equals cookies. And let's save that. Resp equals log.info resp.status code. So if we get a 200 in this response, we'll know that we've got it signed, the server accepted it, and of course we failed here. Oh, we need to also modify the freaking somewhere here. Decode, we can do that. Let's what is it? Underscore JWT dot modify part. We're gonna modify the head. What we're gonna modify is the algorithm, and we're gonna change it to HS256. And then we can log the new head, then sign it. All right, come on. Dang it. I didn't fix this, whatever it is. JWT object has no key. That's an error from, where is that? 38, line 118 in my JWT library. Boom. Let's go to 118. Whoops. G. Make signs self.key. Oh, we need to save that. So we can do. Oh, we can just provide it when we sign. Sign JWT key. We want signed here. The secret. We don't want sign JWT key. We want sign secret equals. And what did we PEM? What I'd forgot is that now that we're HS256. Oh my gosh. Look at that. Wait, what? No, it didn't work. Session. Oh, that's right. It's because this only returns the signature. Sig equals that. And then we want to encode the new. So we want a underscore JWT dot encode right here. Encode with the new sig. Sig equals sig. Now let's try it. We got a 200 and look at that. That's freaking awesome. All right. All we have to do now is change our user. Let's do that right here. JWT.modify part. We're going to modify JWT.body. And we're going to change the sub from Wiener to administrator. To run this again. This time it should tell us that we accept our token, show that we're administrator. My account. Yeah, your username is administrator. And finally, let's add in the delete Carlos and freaking solve this. Let's this. So we're gonna get the admin page with cookies set. Then we're gonna delete Carlos and check if it's solved. All right, here we go. Drum roll, please. We're gonna freaking solve expert level JWT algorithm confusion with a Python script. Boom! Lab is solved. Let's get our banner. There we go. All right, sweet. Let's walk through. Thanks for the cool words, Frank. I appreciate that. Let's review what happened here. So this is algorithm confusion. So just to reiterate what the vulnerability was. The vulnerability was that the application used RS-256, but it also had the ability to use HS-256. HS-256 uses a secret when signing the message. RS-256 uses a PKI, so a public key and a private key. RS-256 will sign with a private key and then verify with a public key. The way that the application was written was that it says if it's HS-256, I'm still going to look for the key identifier, still looking at that file to get the secret. Now that it's HS-256, it's looking for a secret. So it takes the contents of the key file and uses that to sign the message And that's how it does its verification. So when we created our token, we were able to grab the public token or public key from that the JKS, where is it? JWKS.json. Here's the information. So we got the modulus here, the RSA modulus, and we've got the public number, the exponent there. And that's all we needed to be able to convert this from a JWKS to a PEM. We signed our modified token with the PEM we created. We had to make sure that the PEM was a byte for byte, exactly the same as what the server would use. When the server received it, it saw that the new algorithm, it saw the algorithm was HS256. It saw that the key identifier, or what where it looks to get the key to sign it, was the same that it used for RS256. So it grabbed the public key and hashed the message and then compared the signature, this part, right to here. It compared that with what we signed it and said, oh, those are equal. I now trust everything that's in this message. And because we were able to modify it from Wiener to administrator, we got logged in as administrator and solved the lab. Pretty freaking awesome. If you have any questions, definitely let me know. Otherwise, I'll see you in the next one. Thanks so much.